Okay, just to make one last point about correlation, here we have a scatter plot for two variables, the relationship between two variables x and y. Um, and so we can ask, is there a relationship between x and y? And clearly there's a relationship between x and y. What we mean by that is uh, if you know x, can you make a fairly good prediction about what y is going to be? And yeah, you can, right? If you know x is over here, you're going to predict y as low, right? If you're here, you're going to predict y as high. And if you're here, if you have x over here, you're going to predict y as low again. So yeah, there's definitely a relationship between x and y. That means you can make a fairly good prediction about y given knowledge of x. But r, remember r, the correlation coefficient, won't capture this relationship because it's not a linear relationship. So r is probably going to be fairly low for this, even though there's a very strong relationship between x and y. So just because r is small doesn't mean that there's no relationship between the two variables. It just means that there's not a linear relationship between the two variables. Okay, now let's go back to this. All right, so now we want to talk about regression. Let's read this. Linear straight line relationships between two quantitative variables are easy to understand and quite common. We found linear relationships in settings as varied as sparrowhawk. Okay, so let's go on to when a scatter plot shows a linear relationship, we would like to summarize the overall pattern by drawing a line on the scatter plot. A regression line summarizes the relationship between two variables, but only in a specific setting. One of the variables helps explain or predict the other. That is, regression describes a relationship between the explanatory and response variable. Regression line. A regression line is a straight line that describes how a response variable, y, changes as an explanatory variable, x, changes. We often use a regression line to predict the value of y for a given value of x. So here we have some data. You can see the blue dots. They've drawn in a bunch of other stuff as well, but we can see the blue dots. And the x-axis and the y-axis. The x-axis is what? Percent of adults returning and number of new birds. So what is this? Data on 13 sparrowhawk colonies with a regression line for predicting the number of new birds from percent of returning birds. Maybe we have to read this a little more carefully. See what this is about. Percent of, well, it doesn't say very clearly here. But so as the percent of adults returning increases, it looks like the number of new birds is decreasing. Okay? So anyway, we have these dots, and we can try to draw a line that sort of expresses the relationship between these two variables. And that's the red line there, and that's called the regression line. They also tell us that the correlation for this data is r equals negative 0.7485. So it's a fairly strong relationship between the two variables. And they also say that we can use, if we can draw in such a line, like the red line, which we call the regression line, if we can draw that in, then we can use it for prediction. By that we mean if we say that the percent of adults returning is 60, then what would we predict for the number of new birds? And we'd use the line, and the way we'd use the line, of course, is we'd start at 60, go straight up, and when we get to the line, then we'd go over to the left and see what the y-coordinate of that point is. and so it looks like it's about 14. And that line, how do we obtain this line? So different people might draw in different lines. Probably nobody's going to draw in exactly the same line. So that's not a very good situation. We don't want to have everybody drawing their own line. So we want some method for obtaining the line. And the method that we are going to use is called the least squares regression line. So here we see another set of data. You can see the little orange points here are the data, and you can see the red line here. You can see the orange points down here. And we can talk about the prediction error. So if our prediction line, our regression line, is the red line, then the actual data point is here. But if we have percent of adults returning is about, what is this, about 66 or something? If we use 66, the actual value was what? We go here and it was actually 6, right? But if we use the regression line, how would we use it? We'd say 66, we'd go up to here, we'd go up to the regression line, and then we would predict that there are going to be 12 new, the number of new birds is going to be 12. So the actual value was close to 6, and the predicted value is close to 12. So this length here is called our prediction error. Okay? We could do the same thing here. This is about, what, 73? So the actual data was 73 for x, and about 12 for y. But if we use the prediction, the regression line, we would say 73, we would predict maybe 10 for y. Okay? So this is called the prediction error. So here they say the predicted response for x is 74, so when x is 74 is 9.438. The observed response, the actual y variable, is 5. Okay? So we want a method, we want to choose a line which minimizes these prediction errors. So if we choose a different line, we're going to get a different set of prediction errors, and we want to choose the line which minimizes those errors. That's called the least squares regression line. The least squares regression line of y on x is the line that makes the sum of the squares of the vertical distances of the data points from the line as small as possible. So it's not exactly these distances. We actually square these distances, and the reason is because this distance will be a negative distance, and this distance will be a positive distance, and if we didn't square them, they would cancel, and that would sort of get in the way of our method. So we square them first, just to basically just to eliminate cancellation. So it's called the least squares regression line. So the way we write it, so this is a line. So every line has an equation y equals ax plus b, or we can express it that way. And so we want the equation for the line given a set of data. Given a particular set of data, what line should we get? We're going to express the line as y equals ax plus b, and we're going to need to know what a and b are. Once we know what a and b are, we know what line we're talking about. So they use y hat there. You can see there's a little hat above the y. And that y hat means the predicted value, as opposed to y, which means the actual value. Okay, so since we're talking about the line, not the actual data point, but the point on the line, we use y hat there. So once we have a set of points, we want to find the regression line. We want to find y equals a plus b. We need to find a and b. So this is what we're looking for, and it turns out that b will be equal to r times s sub y over s sub x. Well, we saw all of these symbols before. R, we just finished talking about R, was the correlation coefficient, and S sub y, we already talked about that, and S sub x. So if you calculate those from the data, then you can calculate B, and then you'll know this B here. Then you only need to know one more thing, and that is the A, and the A apparently is obtained as y bar minus b x bar. And these are also things that we've already talked about and things that we can already calculate. So therefore, once we have the data, we can calculate the a and the b, so we can know the equation for the regression line. So once we have the equation, then we can use it. We can use it for prediction. So for example, the line in figure 5.1 is in fact the least squared regression line of new birds on percent of returning birds. Enter the data from exercise 4.4 into your calculator and check that the equation of this line is this. So you can actually figure out the a and the b, and you given a set of data, so given the data that they had above, you can figure out what the a and b are, and therefore the regression line. Okay? And then you can use it for prediction. For example, they say to predict new birds when 60% return, when x is 60%, can you predict y? Yeah, you just put in 60 into the equation and you get the value for y. Okay, so I'm going to show you how to do this in Excel, but before I do that, well, actually, let's look at that now. Let me stop here, and then I'll do some Excel, and then I'll come back to this.